Hi and welcome, I'm Mr. Simons and I welcome you here to Simons Maths. Right, in Simons Maths I'll be doing a whole series of videos per topic as per work that must be covered in class, and I'll try to cover most variations. So without further ado, topic 1 for the year grade 11, exponents and surds. We're looking at basic laws and rules of exponents. It's work that should have been covered in grade 9, 10, 11 this year, and we're just revising it again. Right, so first law of exponents. Before we start there, exponent a to the power n is referred to as exponent. The base there is a. N is the index, but also referred to as an exponent by most teachers. So per definition, the exponent a to the power n simply means a times a times a to n factors. Right? So if n is 7, I would have 7 a's multiplied with. If I have n is 5, it would be a times a times a 5 times. Right? N is a rational number and a can be any real number. Alright, so first law, a to the power m times a to the power n. If we multiply and the bases are the same, you see that is a and that is a. We add the exponent m to the exponent n. So there a m plus n. Right, so when we multiply and the bases are the same, we add the exponent. So here's just an example to show you. So I have 3a to the power 3, c to the power 4 times 4a5, c negative 2. Right, so first we multiply the coefficients. So 3 times 4 gives me 12. A and a there in purple, as you can see, are the same bases and we're multiplying there. So therefore 3 plus 5. Same with c. In blue, bases are the same, so we add the exponents. 4 minus 2. So 3 plus 5 would give me 8. 4 minus 2 gives me 2. So my final answer, 12a8, c2. Right, we come second law of exponents. So the second law, if we divide and the bases are the same, we subtract the exponents. So you see base A, therefore we say index m minus index n, m minus n. So when you divide and bases are the same, we subtract the exponents. So here's a typical example, basic. There we have base 2, both in blue, and base B both in purple. So if the bases are the same and we're dividing, we subtract the exponents, so that becomes 4 minus 2. That becomes 5 minus 2. So that gives me 4 minus 2 is 2 and 5 minus 2 is 3. So my final answer, to the power 2, p to the power 3. Please, if you're enjoying the videos, please like, share and subscribe. Subscription will give you access to a whole bunch of videos that will be uploaded to assist you in your mathematics. Right, third law of exponents. Right, if we have an exponent in a bracket, a to the power m, and it's raised to another exponent outside, or one power is raised to another power, then we say we multiply the exponent, so that becomes m times n. So when raising a power to another power, we multiply the exponents. So there I have base p, exponent 5, and on the outside 3. So 5 times 3, p to the power 15. So that's basic third law. Fourth law of exponents is simply when I have more than one exponent in a bracket. So I have a to the power m, p to the power 1, and all this is raised to a further power n. So then we multiply, so m times n, and then 1 times n. And m times n is simply written as mn. And n. So whenever we write two letters next to each other, it simply means multiplication. So when two or more bases are multiplied and raised to a further exponent, write each one to the exponent. So therefore, as a invisible 1, a to the power 2, p to the power 5. So 1 times 3, 2 times 3, and then 5 times 3. So 1 times 3, 2 times 3, 5 times 3 gives me 4 to the power 3, a to the power 6, and p to the power 15. Right, so that is your basic 4 laws of exponents. Next slide, we're going to look at some definitions or rules of exponents that were discovered from solving problems. So definition for m and n, if it's an element of natural numbers. So anything raised to the power 0 will always equal 1, but take note, a is not allowed to be 0. So a may be positive or negative, but not 0. 0 to the power 0 is undefined, as per schoolwork. Right? A negative n, right? If I have a negative exponent, it must always be written as a positive exponent in all our problems that we're going to do in the next videos. So they have 1, take n to the bottom to make it positive. A cannot equal 0 because if we divide by 0 it would be undefined. Right? If it's not clear, you can look at the third definition here, or rule. If I have a negative exponent, I can take the negative exponent inside the bracket, so that would become a negative 1, b negative 1. To write them as positive, b goes to the top and a comes to the bottom, so b a to the power n. If you look at the example there, negative 2, I can take the negative in, so 2 negative 1 comes to the bottom to become positive 2 to the power 1, and 3 negative 1 goes to the top to become 3 to the power 1 squared. 3 squared is 3 times 3, which gives me 9. 2 squared is 2 times 2, which gives me 4. Right, and then if we have a fraction, a over b raised to power x, we say 1 times x and 1 times x. A to the power x, b to the power x. So there, 2 to the power 1, 1 times 3 gives me 2 cubed. 3 to the power 1, 1 times 3 gives me 3 cubed. So 2 cubed is 8, and 3 cubed equal 27. Right, so that concludes our first lesson. In the next lesson, we will look at your exam questions and classwork questions that should be asked in order. Right? Enjoy.